Welcome to the second movie of Chapter 1, Paragraph 1.2. It's Pure Substances and Mixtures. And if we're going to talk about mixtures, it's first a good idea with science, especially with chem, to talk about what a molecule is. So we're going to start with that. And afterwards, I'm going to explain what in science a pure substance and a mixture is, because in science tea is not a pure substance, even though you have pure tea, but it's a mixture. And we're going to talk about solutions and suspensions and what things we do with that. So we got a huge list of words, and basically this is the word list you should have in your notebook at the end of the movie. And there is also some picture to explain what's going on. But before I'm going to explain what a molecule is, we're going to take a look at a movie. It's called The Powers of 10. And we're going to go down when it gets smaller. As you can see, it already has other things when it gets bigger, the universe and everything. If you want to see it, just go to YouTube and take a look at this movie from the beginning. We're going to start it when it goes down from like a meter and see what we see. Okay. And each step is a tenth of the one before. So we have this square is 1 centimeter, and we see the skin. And this is a millimeter, so we're approaching really the surface of the hand, and we're going inside the skin as well. And we're going to go to a capillary. It's a very small blood vessel. Okay, so we're looking at part of a blood cell right now, and as you can see, this square is 10 micron, and a micron is a millionth of a meter, so very small. Okay, and right now you can see this the big part is 1 micron, a millionth of a meter, and you can see the DNA, and the DNA is the biggest or one of the biggest molecules we have. And that molecule, if we change it, we change the DNA, we change the hereditary information of that man. So basically this molecule is the smallest bit that's, and if we change it, we get something else. We get a different DNA for a different person. The same of lots of other materials. If we change that molecule, we change what it is. And normal molecules, for instance water, are much smaller. They're measured in nanometers, and a nanometer is a millionth of a meter, and water is like 10-20 nanometers big, so it's very, very small. And if you break down that water molecule, you get something different. So this is oh, I need to stay in my browser. This is basically what a molecule is. It's the smallest part of a substance that still has the properties of that substance. And what is a pure substance? A pure substance in science is a substance that only consists of one type of molecules. So it's the same everywhere, the same molecule everywhere. That mixture is then a substance that consists of different types of molecules. And then we can have different types of mixtures, and here you can see two types. This is a solution and this is a suspension. And over here the T is a solution, and you can see it's clear. If you water it down far enough, you can see through it. And if we go down and it's a mixture, with T, it's a mixture of a solid with the water with T, but you can also mix some other liquid in it, or if you got bubbly water, you mix a gas in it. And if you go down to the molecular level, you can see that the molecules are evenly distributed, that it is really through and through mixed. And this is a solution. It's a mixture of solids, liquid, gas with a liquid, and it's true and true mix, which is true and true mixed, and it is clear. So it's all these three things. And this liquid in which something else is put into is called the solvent. It's what you dissolve something into. Solvent, the liquid into which something is dissolved. And it dissolves, so if we make tea, then water is the solvent. You can also have different solvents. For instance, if you if you have pen on a table, then water won't dissolve the pen, the ink, but sometimes alcohol will. So then alcohol is also a solvent. And the dissolved substance is what goes into the solvent. So that is the substance that is dissolved into the solvent. And that is the solution. And we go to the suspensions over here. You can see it looks different, and it has names, how it looks like, that you might not are familiar with. So that's why I wrote it down. It's turbid or opaque or cloudy. And basically that means not clear. And if you water it down, you can't look through it. And then what is a suspension? Well, you have this is with sand in water, but you could also have it with chalk in water. And then it's a solid with a liquid. And if we look at it at the molecular level, you can see it is not mixed through and through. You have small clumps of the solid in the liquid. And the other thing about it is not clear, that it is turbid or opaque or cloudy. Please note that turbid, opaque, and cloudy are synonyms. So, what is a suspension? A mixture again of a solid and a liquid, which is not mixed through and through and is turbid. Okay. We make solutions ourselves, and we can separate them, because if we have mixtures, we need to separate them, and that's where chemistry does a lot of things in. And one of the things, if for instance, if you make a cup of tea, then you need to have some part of the tea leaves into your water. That's what you want, and you make tea. And the part that you want in the tea leaves, they can solve. And if you do that, if you solve part of the mixture and leave the rest behind. That's called, with a different code word, extraction. So it is a separation method. It separates a mixture. And it is based on solvability. And another separation method is, for instance, if you have here your suspension, and if you want, that is, for instance, if you make coffee or also with tea, then you want to have what is the grinded coffee you don't want in your coffee, the tea leaves you don't want in your tea, so you filter it. And then the grinded coffee, those are the big chunks, and they cannot go through the holes in the paper, in the filter paper, so they're left behind. And the molecules themselves, they can go through it, and it doesn't really matter how big the molecule is, it's that they are separate, and these are lots of molecules together, so it's a big chunk. So the big chunks can't go through, the single separate molecules can go through. And then you separate it as well. So this is based on particle size, not on the size of the molecule, but on the particles of molecules that stay together, big chunks, big particles, single molecules, small particles. So it's also a separation method. And it is based on particle size. And if we take a look at it, we get two things with if we filter it. Some parts are left behind in the filter and some is passing through the filter. What is left behind in the filter is called the residue, and what goes through the filter is called the filtrate. So the residue is what is left behind in the filter, and the filtrate, what went through the filter. Okay, hey guys, lots of things, different things. Please make sure that you have these words as a word list in your notebook, because this is just your vocabulary, your vocab you need to know. Hey, see you in class. See you then. Bye.